Hello, good morning. We continue with next topic in this track. Let me welcome Manuel Schuller to the stage, who is going to talk about GitOps and continuous delivery events. Manuel is a senior DevOps evangelist with a huge experience in Dev and Ops solutions, ambassador of DevOps Institute, and so on and so on. But I personally like this, how Manuel calls himself, like DevOpsifier and DevOpsologist. Yeah, I like these names. Sounds funny. So Manuel, now we have some time for your talk, and audience can ask their questions in the chat. And in the end, we will have like 5 minutes for you to answer these questions.
Okay.
So you're welcome.
Good. Okay, so let's start. Thank you very much for the introduction. As you mentioned, we will talk today about GitOps and CDevents, especially seen to achieve compliance in software delivery pipeline, which is, this is the topic, the main topic, pure DevOps of the track today. We will go through a very quick introduction. I can hear some of you, my God, this guy is still using the software is eating the world picture. I do that because I had the chance to work with Mark Andreessen, who is the guy who said that back in 2011, if I remember correctly. So as you mentioned, I have a huge experience, which means a long career. Within several vendors, several companies doing both dev and ops, and DevOps and DevSecOps. And we will talk today about that GitOps and CDevents solution that we have created with several teams, that allow to make sure that every software that goes to production is compliant. We will see what it means, to what it is compliant, and that we can prove the compliance with a couple of clicks in the solution we have created. So before going into the solution, I like always to talk a little bit about history. We are in the software world. The software world is quite young at the end of the day, but it has an interesting history. So over the last 25 years, especially in the financial services, but not only, we had that history. For applications, for infrastructure, we used to work with monolithic application. We've gone through client server and tier application. Now we are more microservices focused. The infrastructure at the very beginning was the mainframe, open systems. Then we are today in a more container centric, thanks to the cloud. So things that have evolved a lot. The main evolution, though, is the following. We had big applications, so few releases of these big applications. We were talking about big bang for new versions, new releases of applications. And we are now with more modular applications, which means many releases, because we are able to release very small pieces of application that are independent. So it's completely different. And we've gone through some, I would say, some waves, okay? Some waves of the software development. These waves from roughly when I was born until now has gone through some levels of maturity, okay? DevOps today, or DevSecOps, is currently the highest level of maturity. We are going through new path like AI, for example, but applied to what we know today. So if we want to summarize, we've gone through languages, we applied some methods, we've been talking about product and process, and now today is really what we call DevOps. This is characterized, the transition to DevOps, with the deployment frequency. Remember my many few small applications with a lot of releases. It means a lot of deployments towards the target platforms, towards what we will be interested in today, towards the production platform. If we go a little bit more in details very quickly, how that DevOps tooling has matured. If we start from the beginning, we had very simple things, job-based. You remember my mainframe or my early open systems, a lot of scripting, which is difficult to scale, difficult to manage, expensive, because people were quite often changing jobs. So maintenance was a nightmare. We've done that first step through maturity to something called pipeline-based, with some reusability, with the notion of different stages in the pipeline to handle what we have to do. The tools, very simple. Version control, the first one everybody could remember, of my age, could remember Unix in the early 70s, which embedded the first version control system, a CCS, to manage the sources. So scripting and moving to environment, to stages, to transitions between these stages, to model the pipeline. The best practice were I wrap the script to orchestrate into a pipeline already. Even with a poor knowledge, at least the scripts were working, so I could use these scripts, and I could do a basic level of security. Transition, the second to the third generation. Since I have the pipeline, I can add several things like QA, like testing, like security. So basically from stages and environment, I am moving through adding the peripheral activities to my pipeline. In terms of best practices, I can ensure that I better manage the environments and what is in the environments. I can have repeated activities. I can have a better knowledge of what I'm doing, what I'm releasing, where it is released. It will be, by the way, we will see that in a couple of slides, the first step towards the bill of material, knowing how my software is made and where it will be deployed and operated. But in terms of still of best practices, I can add from here other activities, the change management, for example. I can add the requirement management. So build a complete chain to make sure that I do the requirements of my software, I implement my software, and what I will release can be managed and controlled with change management against some initial requirements. Obviously, security is always around, so I can add more security and make sure, for example, that I can move to the next stage only if my QA tests are correct, which is something that we all know today, but only if my code scans are correct, only if my security scans are correct, and so on. So, last step, from prescriptive to configurable. This is what we have today. A complete release automation, release orchestration that does the link with basically from a code commit in GitHub until the release in production of my new application. That kind of solution usually is model-based. So I have a model of how the software should be released, and I will apply that model to my many software versions. So from hiding QA and test and CI and so on, I have a proper DevOps platforms that will cover all the aspects of my software delivery supply chain, which includes, and this is where I want to go, the audit trail. Since I have everything automated in my platform, I can prove, I can easily have the evidence of everything I'm doing through the approval process, through the security and compliance. I can have the reporting on that, very simple, and I can also be maybe more user-focused, developer-focused, and have a self-service capability to onboard the application, but also to verify the audit and compliance through that self-service portal or platform. So I reach a level of maturity that goes through the different generations, a level of maturity that normally could allow me to have the control of the releases, the control of the deployments, and the easiness of compliance and audit. But in the facts, I have some challenges. The common challenges in financial services, or maybe some other things. So there are many challenges. The one I decided to focus on today is the security and compliance. This is the one we are talking about. This is the one we address with that solution based on GitOps and CDevents. So why do we have these challenges, by the way? I just put that slide because on the right corner here, bottom corner, I have a very basic drawing. You will see. Why do I put that very basic drawing? Because that drawing, I think I first used it, I don't want to lie, but it was 30 years ago. The wall of confusion between development and operation, and this is still the case today. Okay, this is what DevOps addresses or tries to address, but we still have some difference of visions between development and operation. We are moving towards the resolution of that, but think about big companies. Big companies have some organizational structures that are moving. Also because big companies acquire some other companies around the world. This is the case for big banks, for example. They concentrate and they bring on board some new organizations, some new groups, some new tool chains that have to be included in that notion of global solutions that work for every software that is released, whatever the technology, so stack of hardware, whatever the release team and the usage that they have, whatever the software licenses, whatever the processes that are applied. So these challenges, because there are many, this is typical of an boring slide. Okay, so I will obviously not go into everything, but we are spending a lot. We don't have enough visibility, and we are losing people and business, which are the three most important things that we are trying to solve in terms of DevOps processes and simple processes in my software delivery supply chain. It translates into figures. It translates into money. Unnecessary spending, I'm losing some money. I'm spending too much money. Visibility and control, I'm losing time, hence money, to have a better visibility and to ensure that I have the control. And I'm losing people in business, so it's directly for both of them money, because people is not happy to work, or I'm losing also business because customers are not happy of the way my software is available, or my software is bugless. So everything translates in money, and I have to change that into a new approach where I will have better compliance audit, better quality of release, better smile in my teams, and I will have less money spent in duplicated hardware, where the cloud is part of the solution over time. So I will reduce that over time, and I want to do that introducing flexibility, visibility, control, scalability, reliability. So my impacts, okay, that reduction in everything that I was talking about. Efficiency savings, risk mitigation, which are interesting things, but the money is still there. So return on investment. How much shall I spend to get a working solution? And what is the return on investment? How much can I expect to save and to earn after that? So if we look at a typical return on investment of that kind of solution, the return on investment is very, very fast. Okay, around, this is an average, average / best case. I have my return on investment in less than half a year. Here I have 5 months of return on investment. So after that, my cumulative investment are in red, my benefits are in blue. I have only benefits of my working solution. So, working solution. What are we talking about? The title was using GitOps and CDevents. Some of you may not be familiar with this notion. So what is CDevents? It's a project of the Continuous Delivery Foundation. As we said in the introduction, I'm an ambassador for the Continuous Delivery Foundation, and I'm working a lot for and with CDevents. It's quite simple. It's about adopting continuous delivery and incorporate whatever tooling best suits for the specific requirement. So it's not linked to a tool, but it's the common specification for continuous delivery events, for the interoperability of what happens in the software delivery supply chain. So what I can do with CDevents, I can have flexible pipelines, easy to scale. I can have synchronizations between workflow, and we will see that in details. I can have a simple way to enhance or modify my workflows, and very important, standardized notification for compliance and metrics collections. So I can collect information, and I can have the automated compliance with the help of CDevents. If you go to the website, the CDevent website, you will find those schemas. Basically, things happen on my system A on the top. Things happen on my system B on the top. I will synchronize the events so that at the end of the day, when I deploy, I have a full product made of system A and system B that work together. Another way of seeing things, still very simple. In the middle here, I have some kind of broker. Things happen on the top here on that drawing, on that schema. SCM, testing, QA, building, generating artifact, doing security checks, deploy, and everything will be sent to broker. And from the user point of view, I can view, I can store, I can notify, I can generate metrics based on what happened on the top. So you see the idea. I made some information available, and my broker will help me use that information for whatever I want. So whatever I want, in my case, will be make sure that my software is compliant and make sure that I've done the right things, whatever it means. We will go a little bit more in details for releasing my software. The second principle in the title was GitOps. GitOps, probably most of you are more familiar. This is the definition you find on the GitOps Wikipedia page, I believe. Operational framework that takes DevOps best practices used for application development and applies them to infrastructure automation. So GitOps is much about automation. You remember my history of the DevOps tooling. If you go to the GitOps webpage, you find exactly that. This is roughly the same, okay? And I discovered, I swear, that GitOps history, okay, the infrastructure automation versus the cloud operating maturity model maturity, I discovered that after I built that part of history of that presentation. This is roughly the same, okay, from programmatic automation until the complete automation of the platform aspect. GitOps, still on the website, you have several schema. I took two of them because we have the two principles that we've been using. The first one is to have a single source of truth. This is very important, not only sorry, for the source code, but also for all the results of the different checks I will do to make sure my software is compliant. The second thing is automation. GitOps is able to trigger a pipeline every time something is committed to Git. So based on these two principles, we have defined the solution. So what? Okay, so what happens? In my software delivery supply chain, basically I have a lot of stages because a lot of teams are doing a lot of activities, but roughly I have three main steps. I have several uncontrolled stages. Uncontrolled means that I can have an environment that is built on the fly. I can have some data that are not yet equivalent to the ones I will manipulate in production. I'm doing some testing. It can be security testing, it can be quality testing, it can be against requirements, so SIT, UAT, all that kind of testings, until I reach a stage which is I will go to pre-production to prepare to switch to production. Okay, so knowing these three pieces, the three parts of my supply chain, this is what I have created. So an execution phase for the checks and a validation phase for the checks. This is in the validation phase that I will make sure that I have the compliance, whatever it means, we will see that, the compliance before sending to production. So how does it work? GitOps will trigger a pipeline. Since the pipeline is a generic one, a generic mechanism, generic process, I have to know what is, for example, the technology I will deploy to. What is the type of software I will deploy. Is it microservices? Is it a mainframe program? Is it client-server stuff? Shall I deploy to cloud infrastructure? Shall I deploy to my data center? Because still some companies, especially some banks, have some data center in some countries that are very touchy. So I have a parameter file that tells me this is what I want to bring to production. So some of the security controls will apply, some of the checks or compliance check will apply or not. Everything is in my parameter file. Since I want to be user-oriented for that parameter files, I also provide templates. This is the typical parameters you have to use if you are working with microservices. This is the typical parameters you have to use if you use Docker files, if you are working on mainframe, if whatever. Okay. After that, according to what the parameter files defines, the software will go through a number of checks. Okay, checks for the security, for FOSS, for SAS, for DAST, for whatever, all the scans that you can imagine, but also other checks. Okay, in my example, in the company where we've been working, there are 17 chapters of controls to evaluate the compliance. 17. Security is one of them. So you can imagine data management, architecture, and so on and so on. So documentation is also a very important one. So it will go through a check of everything. Once I have done the check, I have stored some values. These values, typical, this is where I'm thinking, you remember my single source of truth in the GitOps principles. These stored values, I will try to put them in that single source of truth in one place. This is still something we are working on. So far, we have in several places. We have only one information of one type, but some of them are stored in the ITSM system. Some of them are stored in the policy engine. Some of them are stored in the software bill of material, according to the use I want to do of that information. But the idea is I have one information in one place, which will allow me to validate the controls. I do a very simple example. In my SAST scan, I have to make sure that I don't have any critical violation. Okay. If I have one critical violation at least, then the control static scan will not be validated and the application will not be allowed to go into production. And we will do the same with all the different controls, able to produce an audit report so that the person in charge of analyzing the result will know why the application did go to production or why the application did not go to production. Okay, so basically this is the global idea, the global process that we've been creating. How does it translate? So we'll go through a number of screenshots that show some of the interesting aspects of the pipelines and the processes. So you've seen the title, my security checks, my generic security pipeline. What does it answer to? It answers to the following. I want to do CI/CD, I want to be compliant, I want to build a bomb, because you may remember 3 years ago, 2021, Biden has issued an executive order for applying the software bill of material to any software. It has been then relayed with the Cyber Resilience Act in Europe, but not the project application business focus. Development, although we are all talking about shift left, development is not necessarily a security specialist. It's not made of security specialists. They are very, very skilled in security, but how to define a compliance scheme, a compliance engine for the security, it's not exactly their main focus, their main job. So the specialist team define for me the security, the compliance through a number of steps I have to go through for implementing security. What happens in terms of security in development, in integration, in delivery, and so on and so on. This is what the pipeline can look like, visualized like a Kanban-like activities. And if I focus on one stage, for example, before entering the stage and after for exiting the stage, I have some rules to comply to. Did the user go through the training so he can understand the result of the SAST? And what are the result of the SAST? Did go through the threshold for, in my example, those tools, SonarQube, Checkmarks, IQ Server. You understand here that my process is independent from the tools. I've been using those tools in my examples because they are some kind of market. They are very familiar on the market. It can be any other tool that I can implement over there. Same thing for pre-production. I can exit pre-production and go to production if I have some rules that will allow me to go into production. So my green check going into production. So this was for security, but the application itself, so my mainframe or client server or microservice application, what are the questions? I still want to do CI/CD to be compliant and to build the software bill of material. But I want to do that using the security checks provided by the pipeline I've been describing, building my bill of material and making sure that each stage achieves all the control. My controls, because I want to do testing, but also the generic controls, the one I described in the security pipeline. But you can imagine I mentioned 17 chapters of control. So whatever the control, I want to be able to use these controls. So how does it work? You remember my CDevents before? A way to synchronize. This is exactly what I've been doing. My security pipeline at the bottom, my main release pipeline at the top, and I will synchronize using CDevents. I've done everything in integration. Then I give the information to my main pipeline, which is at that moment in QA. I've done everything, every check for the delivery in terms of security. Then I give the information between SIT, UAT for my main pipeline. So I synchronize using CDevents those pipelines in that way. The beauty of that, so ahead of the pipeline, which is made of my test, okay, dev test, DIT test, a QA test, this is my test. It's not the security ones that are defined by the security teams. But in my development stage, look at that. I have the same conditions. To enter, I have to be aware of what I'm doing. So I'm a registered trainee of the processes. But to exit the stage, I also have to do the same stuff. going to check if the thresholds for my SonarQube checkmarks and IQ7, the same tools that I had before, because it's been done by the other pipelines, but through CDevents, I got the results, and I can check the same results to move my pipeline along to go to the delivery of my application. So I hope this is quite clear. You can imagine the combined pipelines of my 17 chapters. I have a lot of events that go and feed my main software delivery pipeline. While I'm doing that, let's do a quick focus on my bill of material. I was talking about the US executive order that was issued in May, exactly 3 years ago, 2021. The typical use case for the bill of material. We use a bill of material for automation, for compliance, for security, for understanding the complexity of an application. At the end of the day, it's another artifact that contains the description of all the artifacts I can use, I need for qualifying my application. So for those, another reference to Unix. For those who were familiar with that tool on Unix in 75, my God, yet another compiler, YAC. The BOM is a little bit of yet another artifact. It's an artifact that describes the artifact. It's also the single source of software delivery truth. So it contains everything that is used to build the software, but also everything that is used to release the software, including all the results of my scans, for example, all the results of my tests. Just because I can do a scan today and the same scan tomorrow and have different results. So the result can change over time because I've discovered, for example, new vulnerabilities in an open source library. So while the result can change, then my software bill of material have to trace everything. And this is the reason why it's typically escrowed. Just like you do at your notary, you give the notary some important documents so that the notary can have the custody of these documents and will make sure that they are never changed. This is another subject. There are many things I'm doing also in other channels, presentation on SBOM. So if you want to explore that SBOM, just look on Google and you will find some very interesting things. The production stage, by the way, of my security pipeline, I made sure that I have a bill of material of my software entity, typically my microservice, to make sure that before deploying to production, I have the BOM. I have information in my CMDB. If I have a CMDB, I have the immutability of my bill of material, notarized, escrowed, and I have created an SKU. Okay, these are the company's specifics. But I make sure that I can verify that I have my BOM before sending to production. So basically, this is pretty much on the description of the solution. What I wanted to finish with is a couple of lessons learned. It looks very, very simple. I will add one of them on top of that, but so very simple ones. Implement DevOps processes, security controls, automated bill of material. Just do it. Okay, it's easy to do. You remember my history. even if you have a minimal set of tools or scripts, you can wrap them and automate them. It's very important because, and it's the second one, if you don't do it, the competitors will do. And the competitors doing that will get some benefits and will get more market shares than you have. So do follow the state of the art. It's an investment, but it's important to be on the state of the art, because state of the art will ensure that you have the best level of DevOps, DevSecOps implementation to be on top of your market. The third one, yes, quite interesting, because we've seen that automated and self-embedded controls. It is easy that the culture and the best practices will be part of the day-to-day life of the organization and will get disseminated within the organization. The first time a control is implemented, it's some kind of, okay, I have something new, something more to do. If it's done seamlessly with the process that I've described you, then it's easier, because it's painless for developers and operation people. Then it gets, as I said, on the day-to-day life, and then it gets disseminated within the organization. It becomes a normal stuff to do. And if it's not done, people will be shocked, because, oh, we didn't do that. We have to, because it's so simple and it brings so much benefit. Okay, and on top of that, which is quite related to the last one, adoption and preparing the adoption is crucial for that kind of solution. So communicate a lot and involving people in very early stages, so that they can, in those very early stages, measure the benefits and see that their life is becoming better because of it. So we're ending on that. So thank you very much for following the talk. I do not know if there are some questions already on the chat. Excellent.
Thank you for the talk. We have only 2 minutes left, and we have one question.
Okay.
What should be the first step to implement such an approach?
Well, I would say, I mean, it's not an easy question, because there's so much to do. I would do the link with one of the last thing I've said. We have to implement a compliance solution. We have to make sure, because the company has to prove the compliance and to automate, in my case, the compliance of the software release. Every release is compliance. I know that if it's gone in production, it is compliant. So one of the first things to do is to, in my opinion, is involve the people. You remember, adoption work on involving people at early stages, involving the people in the definition of the benefits of the solution. What do I expect from that solution? Okay, I've been told, because my huge company wants to achieve that compliance automation stuff, but for you, development teams, operation teams, security teams, what does it mean on a day-to-day basis? Okay, is there, what is the benefits that you will have in your life? I would start with that. Okay, involving people in early stage and showing the benefits, talking about the benefits, so that we can work together, and you will help me as an implementation team to get these benefits, and I will help you to maybe change a little bit your way of working to achieve those benefits ahead of the technical aspects, which are, at the end of the day, it's I would say it's only technical stuff. Okay, so I hope it answers the question.